And so without any further ado, Elizabeth Basho.
Great. My name is Elizabeth Basho, and my project is about using seabirds as an indicator of ecosystem health in the Salish Sea estuary. As a little background just for myself, through Orca I was given the opportunity to find a great love and appreciation for our local marine birds, and I learned to survey and profile birds, whether just on our local shores, like on Jetty Island with Sabrina and Hannah actually, and even going out on our research vessel, the Fascina, and conducting profiles and surveys and counting and identifying all these birds, and then using some of that long-term Orca data and performing some statistical and graphical analyses. That is all to say, those skills came great in service with this project here. So my overall study focus is using these marine birds to try to pinpoint the effect of climate change on our local ecosystem. Why am I using marine birds specifically? Marine birds are really good indicators. So the first reason is that they are a top-level marine predator, which means that they have a really high trophic level, so effects that are happening anywhere in the food web are going to make their way up to those birds, and we're going to see them. The other reason is that marine birds have a very low phenotypic plasticity, which is a really fancy way of saying that they're very rigid in their lifestyle, their foraging preferences, their nesting preferences, which is meaning that any slight shifts in the trophic web, if one species starts to die out a little bit, those birds are not going to be able to adapt at all, and they're just going to start dying out. So they're really susceptible to any small change. Some of the effects of climate change. Part of my hypothesis is that climate change is going to have some effects on marine primary productivity. So changes in water temperature might cause changes in the water column, which is going to cause different amounts of photosynthetic material happening because they're just not sitting in that photic zone, or they're not able to access nutrients. Something else that could even happen is if there are blooming events where there are not typically blooming events and the birds or fish might not be expecting them, they might not be able to make use of those resources while they're there, and then there's no more nutrients to bloom off of, so they won't be able to have those blooming events anymore. The other reason is bottom-up trophic control. A lot of marine ecosystems have been shown to have bottom-up trophic control, which is meaning that those primary producers and those secondary forage fish levels are going to be controlling upwards to the ecosystem and causing those effects on the marine top predators. As far as data collection, I have two primary data streams I'm working with. The first one is from the National Audubon Society. The National Audubon Society performs a yearly Christmas bird count. Every year, a bunch of surveyors go out, volunteers go out by foot, by boat, by car, and they just count every single bird they see. They have these lovely circles that are 15 mile in diameter. I'm using the data from Skagit Bay, Everett, Edmonds, and Seattle, and I'm using about 30 years of data. The other data set I'm using is the Pigeon Guillemot Breeding Survey from the Salish Sea Guillemot Network. This is breeding site surveys that are going from June to September, which is the breeding season for the pigeon guillemots. They go out every week for 1 hour before 9 a.m. and they count the number of adults, active burrows, prey deliveries, fecundity, survivability, all sorts of lovely factors about these pigeon guillemots. So these are some graphs from my Christmas bird count data. Just to orient you a little bit, on the x-axis here we have year, and the y-axis is the number of individuals cited. What I'm noticing is that there's a lot of variability with these individual points. I think a lot of that has to do with the fact that this is single day data collection. Each one of these points is the number of birds for a single day out of the year. So things like weather or just straight up bad luck are going to introduce a lot of variability. But when I look at these lines, especially with these grebes over here, I'm seeing a pretty significant downward trend. With the alcids, I'm seeing a bit of up and down, but it seems that they are kind of going down a little bit more. Same concept for these graphs, except for these are cormorants and loons, just some different groups to look at. Cormorants, I'm noticing still some variability, but a bit of an unexpected increase, which is a little bit against my hypothesis. And for loons, I am seeing one of the more significant downturns here. I'm really seeing this blue line going down. One thing that's important to keep in mind when looking at these graphs is that the Christmas bird count is volunteer driven, and there have just been more volunteers over the year because the effort has gotten bigger. The effect of that on these graphs, however, is that because there are more volunteers, 100 people are going to see more birds than 10 people if they're covering more ground. So any of these upward trends might be slightly misleading because it might just be a result of having more people out there looking at more birds. And any downward trends we're seeing might be a little more severe than they seem because having more people seeing more birds is making them seem like they're not as dramatic as they are. So we're moving on to the Pigeon Guillemot Breeding Survey next because there's some limitations to the Christmas bird count. A lot of these species are not resident to Washington State and they are migratory, meaning that if there's something going along their migration routes that is impacting their population, I'm not able to control for that and I'm not able to see that in my analysis for this local area. Also, like I mentioned, single day data collection is just introducing a lot of variability that's kind of unwanted. And there is a trophic level time lag. So my entire project, the idea is that primary productivity is going to be affected by climate change, but the effects of primary productivity are going to take time before they reach those top level predators. So I can't really make a super good one-to-one comparison. The advantages for the pigeon guillemot breeding survey is that there's more short-term factors I can look at, like prey delivery and types of prey that are being eaten with foraging preferences, which is going to give me a little insight into those middle trophic levels that I can't really see otherwise. And also, breeding pigeon guillemots have site fidelity, so they're returning to the same nests every year, and also a lot of breeding pigeon guillemots in Washington state are residents, and they're here year-round, and so there's none of that migration issue. There's also just more data in each year, which leads cleanly to my next point, of looking into marine heat waves and anomalous climate events. The general idea with this one being that El Nino and La Nina is a part of the El Nino Southern Oscillation. The idea is that there are rotating patterns of abnormally warm and abnormally cool years. By looking specifically at these abnormally warm years, I can look at marine heat waves to forecast the effect of climate change. So in this year, if there's abnormally warm temperatures, this is the effect happening on the birds. What is that going to tell us about in 30 years when every year is going to be that warm? So I ran some statistical comparisons between these abnormally warm and abnormally cool years to see if there was a genuine difference happening with this data between those two types of years. For differences between El Nino and La Nina years, the warm and cool years, for all of the sites, I found that there was a statistically significant difference, highlighted in blue, for adults counted and number of prey deliveries. Though I'm a little unsure about this data because all of these sites, some of them started collecting data at different times, so it's a little hard to regulate that exactly. So I also ran a bunch of tests controlling for these Western Shore sites that all started collecting in 2011. So adults counted near site and number of prey deliveries I did not find to be statistically significantly different between warm and cool years, but the number of sculpin and gunnel deliveries were found to be different. So there is less sculpin and gunnel delivered on abnormally warm years as opposed to abnormally cool years. That's something really interesting that I'm planning to dig into more about what about the food web is causing that. So for my next steps, the pigeon guillemot survey that I have access to, I got access to very recently. That is why there's not very many visualizations, and that is why a lot of my analysis is pretty new. One of the biggest issues with my statistical tests is that I am potentially performing a fallacy called pseudo-replication, which is because I'm counting the same birds every week, but I'm not treating my hypothesis test like it is I'm telling it is an independent sample, but it's not quite independent because they're the same birds. It doesn't necessarily completely invalidate my analysis, but it just means that I want to do a little bit more work and maybe restructure how I'm looking at it so I'm not encountering that issue as much. I also want to integrate some temperature data. My entire project is predicated on the idea of climate change having effects on this ecosystem, and this project started months and months ago. It started being only about temperature, and then it added birds and lost the whole temperature element, and I'd love to bring it back in now. And the third and final thing to add would be chlorophyll and phytoplankton data. Once again, my entire project is predicated on the idea of primary productivity being affected by climate change. So trying to look at chlorophyll, maybe looking at chlorophyll patterns and how they differ between El Nino and La Nina years, and trying to bring that into my bird data would be a great next step. Thank you so much to my mentors, and a special thank you to the National Audubon Society and the Salish Sea Guillemot Network for providing me data to work with.